Well, I must say I'm getting pretty good. That was 8 minutes, 17 seconds. And usually over 8 minutes, I get kind of antsy. And like 8 minutes is a good time for me. Okay, this is the second part of what God has been teaching me concerning gasification. I've been doing my homework, and the Lord expedites your, you just soak in that information, and through soaking it in, you get to understand the processes and principles in which things work, and having that understanding gives you the wisdom to build or to design any kind of systems. You don't have to go to school. The Holy Ghost is the best teacher in the world. And if you got Him, then you got everything. Okay, as I was doing my homework in Starbucks this morning, sitting back and having my coffee, and I wanted to research, I tried to find the link on where this guy had a chicken farm and is actually taking his waste and gasifying his waste. And he was using the heat off that to heat his farm in the wintertime. And the char that came off of that he sold. And it's too bad that the chicken farmers here in BC wouldn't take note of what this guy is doing. Because all that chicken manure that goes out, that you have to ship out, well, you could be using that for to supply heat and power and hot water for the farm. Your heat basically would be free. And anyway, I don't want to get into that. Maybe at some point, when another time, it could this could be implemented. But sure would be nice. It'd save money, and chicken farms could actually be independent from the system, have their own operation going. Anyway, on this gasifier this morning, they actually went from a single stage Joe pipe application to creating a what I call a Joe pipe reactor. And what a Joe pipe reactor is basically a thermal core device. And if you had like a hexagonal arrangement, if you had a pipe, like a 2-inch Joe pipe in each one, and say your core was about, I don't know, you could probably make it about 24 inches across, like this, from corner to corner, so to give you about maybe 20 inches from width to width, or side to side, and 24 from point to point, roughly. But anyway, each one of the points, you could have one pipe, and about 3 feet long, and in the center is actually that's your geometric core, about 25%, or you could actually increase that to a third of the area, and that's where all your ash would come down the chute, because the Joe pipe would be the core of the Joe pipes would be inserted into like a chute, inserted through. So all the ash that would come up would go into the bottom, and easily for cleanup. So basically, how it works, you have the Joe pipes. The wood gas is made up here, and it comes down on your downflow, right on the outside of your unit. It's almost like a water tower, right, the way it looks. And it comes down on the outside, and it goes into the base of the unit. And as it's coming down, it cools, right? And that's important. And so the gas of the Joe pipe is basically pushed up to the base of the Joe pipe, and you can give it a little bit of push, I guess. And the air actually is brought in from the outside right into the cluster, right into to mix in between the pipes. And in between the pipes is going to be around about 2,000 degrees, extremely hot. So the air that comes in and spins around is going to be superheated almost instantaneously. And the pipes themselves, the way that the air will be injected, will be using that fiance deal that uses the golden spiral or whatever. So you start off at the bottom with one hole, and 3 inches away you might have another, then 1.5 inches. You might have to go further, but anyway, it'd be like one spiral up, and you probably end up having about 8 different holes about the same size. So that's where your air would go in. The further you go down the spiral, the colder the air would be, and so just the induction of the air should cause a swirl. And just to correct any mishap, you also can have a swirl device right above that, and then actually you want your an air tube coming up inside the joe pipe, because you don't want your fuel, your wood gas, and the air mixing together. You want your air to kind of swirl up to create the swirl, and then your wood gas comes up and goes into the eye of the swirl. And so the whole cluster would be about like this, about this high. You don't want to touch it, you won't get near it, I can guarantee you, once you heat it up. That's the basis for the whole unit. So that will sit in a, just like a thing they use on the chicken farm for the grain, like those automatic grain feeders. It will sit in a deal like this that goes up. So this is your hopper here. You can throw in your cord of wood there, and the wood will fall down, and as it's burnt, it's turning into charcoal. And then you have a grate. You cut off about this much of the point, and your pipes would be down here, your grate would be here, and here you'd have, it's going to be a blast furnace. And you could have a lot of air coming through. You could have secondary air coming through from inside the reactor core, the thermal core. And so you actually can create a fluidized bed out of hot air. You know, you don't have to use sand. You don't have to use anything else, just a fluidized bed of air, because the air would be coming up and it'd be fairly high pressure. And then you can inject your steam in there. So that steam would be instantly superheated with the exhaust. I've already seen this and know it works. And so you would have very, very high temperatures just cooking that wood gas. The wood gas would come around and into the base and up. And you'd also have like cooling tubes wrapped around it to extract the heat to help in the cooling process. Very, very hot. So as it's going up, your wood or whatever you're throwing in there, you can throw anything in this and it's going to consume it. And you could have your wood chamber could be 8 feet wide and 8 feet tall if you wanted it. You just have to put it in. That's going to be the hard part. But anyway, as the flame goes through this way, part of the flame goes around the outside of the cone. It's shielded, of course. Comes up and goes into 2 little cavities where you could actually have steam generation. So you can actually generate very, very large volumes of steam while you're generating hot water. And I have this drawn up. I still have to think it through. I want to talk it over with my friend who's built gasification units here, just to throw it past him. But that's it. That's what I was showing this morning, what I worked out in a matter of 2 or 3 hours. And you're going to not just only produce enough wood gas to run the unit, but you're going to have syngas or producer gas to run a small power plant, hopefully. It'd be nice to see this power a 100 kilowatt generator. This morning came across Paul Fung's work about using gasification to power a gas turbine, and this would be probably the best suited for it because of the large turnover of wood gas or pyrolysis. Okay, that's it. I'm going to sign out on this second part.